All right, strap in, everyone, because today we are going deep, like really deep.
Deep into the
You
universe.
got it. You sent us this incredible YouTube video, How Big is the Universe by Science Time. And, well, I think we're going to have some fun with this.
Yeah.
We're going to try to wrap our heads around just how mind-bogglingly massive everything is out there. I mean, we're going to go from feeling like little tiny specks on Earth to grasping the scale of the entire cosmos.
It's like shrinking ourselves down.
Like I Shrink to the Kid style.
Oh, I love that movie.
Right.
Yeah, classic.
Fantastic.
And then hopping in a spaceship and taking a cosmic road trip.
Let's do it.
All right, first stop.
The moon.
The moon. It always seems so close, right? In fact, I mean, we see it up in the sky all the time.
Yeah.
But
It's over 238,000 miles away.
wow.
Yeah. The video actually points out that if you could drive your car to the moon,
At like 60 miles an hour?
yeah, 60 miles per hour, it would take you over 160 days.
No rest stops.
No rest stops.
Yeah. But that distance, it's more than just a number
Right.
from the moon. You can actually get this incredible view of the Earth, this fragile little sphere
Oh, wow.
hanging in the void.
That's beautiful.
Astronauts call it the overview effect.
I've heard of that.
Yeah, and it's this profound shift in awareness.
Yeah.
You suddenly realize how interconnected everything is.
Wow. It makes rush hour traffic seem a little less stressful, right?
Yeah, a little bit.
Yeah.
But, we've got more exploring to do.
Okay.
So let's fire up those engines and head to the sun.
Oh, yeah, to the sun. Okay, hold on tight. So to get to the sun, we need to travel 1 astronomical unit, or AU.
Right, which is about 93 million miles.
Wow. And even light, which is the fastest thing in the universe.
Takes over 8 minutes to travel that distance.
So that means if I could send a text message to the sun,
You have to wait 8 minutes.
8 minutes, just for it to get there.
Just for together, and then another 8 minutes for a reply.
Forget about instant gratification, right? But this 8-minute delay, I mean, this is crucial. It gives us a sense of the scale of our solar system.
Yeah. It helps explain why missions to Mars.
Which is what, like about half an AU away?
Yeah, about half an AU away. It helps explain why those missions are so complex and why they take so long.
Well, they said in the video that a trip to Mars on a commercial plane would take over 50 years.
That's a long flight.
You would need a really good in-flight entertainment system.
You would. But let's skip the layover on Mars for now and push onward to the outer edges of our solar system. Let's go to Neptune,
Neptune.
the ice giant.
The ice giant.
Neptune is a whopping 2.8 billion miles away from the sun.
Okay, so how long does it take sunlight to reach Neptune?
So it only takes over 4 hours.
4 hours. I mean, imagine waiting 4 hours for your tan to start.
Yeah, no quick tans on Neptune.
Nope, not at all. But now imagine traveling even further.
Beyond Neptune,
To where Voyager 1 is.
to where Voyager 1 is currently cruising.
Wow.
This little spacecraft, it was launched in 1977.
Wow, that's before I was born.
Yeah, it's traveled over 14 billion miles.
And it's still going.
And it's still going, still sending back data.
That's incredible.
And, back in 1990,
Yeah.
Voyager 1, it turned its camera back toward Earth,
Oh, well.
and it took a picture.
What?
It's a picture now known as the pale blue dot.
Pale blue dot. I've seen that. It's amazing.
Yeah. In that photo, our entire planet, everything we know and love,
It's just a dot.
it's reduced to a single pixel. And Carl Sagan, he had this incredibly powerful reflection on that image.
He said we should cherish that pale blue dot. It's
Yeah.
the only home we've ever known.
Right. And really makes you think about how precious and fragile our planet is.
Absolutely.
But you know what? Our cosmic journey isn't over yet.
Okay.
We got to venture out even further, beyond the realm of the planets,
Okay, where are we going?
to the mysterious Oort cloud.
The Oort cloud.
The Oort cloud.
Now, what exactly is that?
So it's this vast theoretical sphere of icy objects, and it's thought to surround our solar system.
Oh, wow.
And it stretches out an incredible 100,000 AU from the sun.
100,000 AU. So
And
that's...
that's almost 2 light years.
Whoa, hold on. Okay, remind me, what's a light year again?
So a light year is the distance that light travels in 1 year.
Right, and light travels super, super fast.
Incredibly fast.
So 2 light years, that means it takes light from the sun 2 full years just to reach the Oort cloud.
Exactly.
Wow.
And somewhere within this vast expanse, we find the heliopause,
The heliopause.
the boundary where the sun's influence finally ends and interstellar space begins.
So it's like we're finally leaving the city limits
Yeah.
and stepping out into the true wilderness of space.
A perfect analogy.
I like that.
Yeah. And it's from this cosmic frontier that we'll continue our journey next time.
I can't wait.
Okay, so last time, remember, we made it all the way to the edge of the solar system?
Yeah, the heliopause.
Yeah, where the sun's influence, it like finally gives out.
Right, and interstellar space begins.
Exactly. But this time, we're going even further.
Oh, yeah.
We're setting course for our closest stellar neighbor.
Ooh, who's that?
Proxima Centauri.
Proxima Centauri. I love that name.
It is a cool name.
Yeah, so how far away are we talking?
About 4.4 light years.
Wow.
That's 25 trillion miles.
25 trillion.
Trillion. With a T.
Wow.
Yeah. To kind of put that in perspective, think about this.
Okay.
If our sun were the size of like a grain of sand,
okay, I like
Proxima Centauri would be another grain of sand, but about 25 miles away.
That's insane.
Yeah. We've gone from a tiny pale blue dot to a grain of sand lost in this vast cosmic desert.
So if we wanted to send a probe to Proxima Centauri, like how long would that even take?
Well, Voyager 1.
Okay, Voyager 1.
That's currently the farthest human-made object from Earth.
Right.
And it's traveling at about 38,000 miles an hour.
Per hour.
At that speed, it would take Voyager 1 over 70,000 years to reach Proxima Centauri.
70,000 years. That's just mind-blowing.
It is.
I mean, even with our fastest spacecraft, reaching another star system just seems impossible.
Almost impossible, yeah.
Almost impossible.
But you know what? Let's zoom out even further.
Okay.
Because Proxima Centauri is just one star.
One star.
In a vast collection of billions of stars.
Millions. Okay.
That make up our galaxy, the Milky Way.
The Milky Way. I always get mesmerized by those pictures, you know, that swirling spiral of stars and dust.
Yeah, they're beautiful.
They are. It's hard to even imagine how big it actually is.
The Milky Way is about 100,000 light years across.
Okay.
To give you a sense of scale.
Yeah.
Think about this.
Okay.
If our solar system were the size of a quarter,
okay, all right,
the Milky Way would be as big as the continental United States.
So we've gone from a grain of sand to the entire U.S.
Pretty much.
This is making my head spin. You said the Milky Way has billions of stars?
Billions, yeah.
So that means there could be billions of planets out there, too.
Exactly. And some scientists even believe that many of those planets could be similar in size and temperature to Earth.
So there could be other Earths out there?
Potentially, yeah.
Potentially harboring life.
That's the big question, isn't it?
It is. Oh, which reminds me.
What's that?
The human radio bubble. Can you explain that?
Think of it as, like, our cosmic footprint. So for about a century, humans have been transmitting radio waves out into space.
Right. Radio waves.
Right. But those waves travel at the speed of light. So they've only reached a distance of about 100 light years from Earth.
So any alien civilization beyond that bubble would have no idea we even exist.
That's right. It's like we're shouting into this vast cosmic void, but no one can hear us yet.
So we could be broadcasting to a silent universe.
Maybe.
Or maybe there are other civilizations out there listening and waiting.
I mean, it's a possibility.
It's a pretty wild thought. But, okay, we've explored our solar system. We've explored our galaxy.
Yeah.
What lies beyond the Milky Way?
Well, the Milky Way isn't alone.
Okay.
It's part of a larger group of galaxies.
What's it called?
It's called the Local Group.
The Local Group, okay.
And it contains over 50 galaxies.
50? Wow.
Spanning a distance of about 10 million light years.
10 million light years. So that means...
That means light from those galaxies has been traveling for 10 million years just to reach us.
It's like looking back in time.
It is. We're seeing those galaxies as they were 10 million years ago.
Wow. And what's even more amazing is that the Local Group, it's not just made up of spiral galaxies like the Milky Way.
Right. There are also elliptical galaxies, irregular galaxies, even dwarf galaxies.
So many different kinds.
All sorts of shapes and sizes.
It's amazing how diverse the universe is, even on this massive scale.
It is.
It makes you wonder, what else is out there?
Well, the Local Group is just a small part of an even bigger structure.
Oh, there's more.
Oh, there's always more.
Oh.
It's called the Virgo supercluster.
Virgo supercluster.
This supercluster contains thousands of galaxies.
Thousands.
Okay.
And it stretches over 110 million light years.
The Virgo supercluster. I mean, that just sounds epic, doesn't it?
Yeah.
Imagine all the stories and civilizations that might exist within that vast expanse.
It's hard to even fathom.
But hold on, because the Virgo supercluster is just one piece of a truly enormous structure.
The big one.
Oh, okay, hit me.
It's called the Laniakea supercluster. The Laniakea supercluster.
This is our true cosmic address. It contains the Milky Way, the Local Group, the Virgo supercluster.
And countless other galaxies.
Countless. It's like a cosmic web spanning over 500 million light years.
500 million light years. Okay, so if we could travel at the speed of light,
yeah,
it would take us 500 million years just to cross this supercluster.
That's right. It's almost beyond comprehension.
I can't even wrap my head around it.
Think of it this way. If the Milky Way was a house, the Laniakea supercluster would be an entire continent.
So we're talking about one seriously big neighborhood.
Yeah. And what's even more fascinating, at the heart of this cosmic metropolis, there's a mystery.
A mystery?
A mystery. It's called the Great Attractor.
The Great Attractor. Okay, what is that?
Well, it's a region of space that's pulling everything in Laniakea towards it.
Everything.
It's like a cosmic magnet.
So it's pulling in all those galaxies.
But the thing is,
What is this?
scientists still aren't exactly sure what it is or what's causing this immense gravitational pull.
So we've got a cosmic mystery on our hands.
Yeah, you do.
The Great Attractor. Man, this is fascinating. It makes you wonder what other secrets are hiding out there in the vastness of the universe.
Who knows?
You know, we've covered a lot of ground in this deep dive.
Yeah, we have.
Maybe we should take a break.
Okay.
And then come back and tackle the ultimate question.
What's that?
How big is the entire universe?
The big one. All right, let's do it.
All right, so we've journeyed from our tiny pale blue dot out to these superclusters spanning hundreds of millions of light years.
It's a wild ride.
It has been a wild ride.
For the grand finale.
Big question.
How big
is
the entire universe?
Okay, lay it on me.
So the observable universe, the part we can actually see with telescopes, is about 93 billion light years in diameter.
Wait, 93 billion?
The billion.
With a B.
The universe is only like 13.8 billion years old.
Right.
How can we see things that are farther away than the age of the universe itself? That doesn't make any sense.
You've hit upon one of the most mind-boggling things about cosmology.
Yeah.
The expansion of the universe.
Okay, so explain that to me.
Space itself is stretching, like the surface of a balloon being inflated.
Okay.
So that means that light from those distant galaxies has been traveling for billions of years, but at the same time, the distance between us and those galaxies has also been increasing.
So it's like we're on a cosmic treadmill.
Yeah, like that.
The light is racing towards us, but the space it's traveling through is expanding at the same time.
Exactly.
So we're never going to catch up.
Not quite. And here's where it gets even weirder. Okay, weirder.
Because of this expansion, some regions of space are actually moving away from us faster than the speed of light.
Hold on. Faster than the speed of light. But I thought nothing could travel faster than light.
You're right. Nothing can travel through space faster than light.
Okay.
But the expansion of the universe itself, that's not bound by that rule.
I see.
It's the fabric of space itself that's stretching, carrying those distant galaxies away from us.
At these incredible speeds.
At incredible speeds. So, yeah, there are galaxies out there beyond the edge of what we can see whose light will never reach us.
They're like lost to us forever.
It seems that way, yeah.
Wow, that's kind of sad.
Yeah, it's a little bittersweet. But there's one final mind-blowing concept.
Okay.
The observable universe, as vast as it is, may be just a tiny fragment of a much, much larger universe.
A much larger universe.
Maybe even an infinite universe.
An infinite universe.
Infinite.
It's just impossible to wrap my head around it. I mean, we started with our little planet, that pale blue dot.
Right.
And then we zoomed out to our solar system, to our galaxy, clusters of galaxies, superclusters.
Just keeps going.
Stretching hundreds of millions of light years. And now you're saying this might all be just a tiny, tiny part of something infinitely larger.
Yeah, it really puts things in perspective, doesn't it?
It does. I mean, all of our worries, our triumphs, our struggles, they all just seem so insignificant when you compare them to the immensity of the cosmos.
It's humbling, right?
It really is. It makes you realize there's so much more out there beyond what we can see or even imagine.
Yeah. So many unanswered questions, so many mysteries yet to be solved.
Like, what other wonders are hiding out there? What other forms of life might exist? Are there other civilizations looking up at their night sky wondering if they're alone?
Those are the big questions, aren't they?
I don't know. It's both awe-inspiring and a little terrifying.
I know what you mean.
But I think it's also incredibly exciting. Yep. It makes you want to keep exploring, keep searching for answers.
Keep pushing the boundaries of what we know.
That's what it's all about. Well, that's it for this deep dive.
Wow, that was quite a journey.
It really was. We've scaled the universe from our pale blue dot to the edge of the observable universe and beyond.
And who knows what else is out there.
Yeah, who knows? To everyone listening, Keep looking up at that night sky.
Keep asking those big questions.
And never, ever lose your sense of wonder.
Because there's a whole lot more to discover out there.
That's right. Until next time, happy stargazing, everyone.